again, and today we are going to do experiment based on organic functional groups. One of the primary tests that we do for organic compounds, we test for solubility, and based on solubility, we may not come with the exact functional group, but we could say if the compound is neutral, if it's a polar, or is non-polar compound, if the compound is acid, like carboxylic acid, or if the compound is base, like amine. So we test the solubility. The general rules for solubility is like dissolves in like. When it comes to organic compound, we have like polar functional group. If we have carboxylic acid, we have alcohol, we have amine with limited number of carbons. The cutoff is like 5 carbons. So if you have less than 5 carbon alcohol, it would dissolve in water. Less than 5 carbon carboxylic acid, aldehyde, or ketone, like 1, 2 carbon or 3 carbon aldehyde, or 3 carbon ketone, which is acetone, would dissolve in water because it's polar enough. The functional group is polar, and the carbon chain is short enough to dissolve in water. When we have long carbon chain and then we have a polar functional group, the long carbon chain, which is non-polar, is going to take the priority, and the whole molecule would act as non-polar. So when we test the solubility, let's just go ahead and start the solubility test in water. I have 3 compounds that I'm going to work with: benzoic acid, ethanol, and hexane. So I have 3 of the compounds. I'm going to give about 1 inch based on the recipe, based on the procedure for the experiment of the water. I'm going to dispense the water first in the test tubes. Then I would add one of the compound, and I will try to show it to you what happens based on the solubility. And while I'm doing the experiment, I would also explain the procedure. Okay, so I have ethanol. I'm going to start with the ethanol, solubility of ethanol in water. Ethanol is a small molecule alcohol. It's very polar, so it's going to, we know that it's going to dissolve, but it would be a good test for you to see if it dissolves, how it's going to look like. I just added like 2 drops, but based on the procedure, we add 2 drops of the ethanol, and that's what I have, ethyl alcohol, or 95% ethanol, and I added 2 drops. When I add the drops of the ethanol into the water, 1 layer forms, and I hope that you can see it with the background, white background or black background, what we need. So you could see that is like 1 layer. It's not easy to distinguish if you can see it or not, because it's 1 layer and you would see it 1 layer. It's easy to see the 1 layer. When it's 2 layer, then I would probably work harder to see, to make sure that you could see. It's 1 layer, so it is soluble. When it's soluble, with the first drop of the liquid, we can add more and try the solubility. If it doesn't dissolve, it's going to form a second layer, like an oily layer, and then the aqueous layer, which in that case, we can say insoluble, but ethanol did dissolve and we only have 1 layer. Thank you. We're going to use the black background to see if it makes it better for you to see it. And then we use yes, it's 1 layer, so it is soluble. For the compound that dissolves in water, we are going to check with the litmus paper to see if it's acidic or basic. So this compound, with 1 drop, I add a drop of the liquid to the blue litmus paper. The blue litmus paper remained blue. Okay, it remained blue, and I'm going to test the liquid on the red litmus paper. Red litmus paper also remained red. This means the compound is neutral, because if the compound is neutral, the litmus paper doesn't change color. But so we cannot use just one litmus paper. We have to use both of them, because if it's base, it would keep the blue also blue, but it would turn the red litmus paper to blue color as well. But if both of them remain the same, it's not going. It means that it's a neutral compound. So to the second compound, to the second test tube that I have, I'm going to add the hexane, which is a non-polar organic molecule. Because these are known samples, so we are going to just test with the known sample. We are learning about the technique, how to test for solubility, and we are training our eyes to see how insoluble compound would appear in the solvent. So if I just look at it like this, it may not see that it's not soluble, but when I shake it vigorously, then I see that these droplets of the liquid, like a droplet of oily compound, is coming down and is going back up. Going to add extra drops to thicken that layer. So you can see the two layers are forming. Maybe without the background, you could see the two layers are forming. There's like one layer or maybe a white background. No. Okay. So if it's hard to see it, or because it's hard to see it, I'm going to add more. When you add more, that layer gets thicker. And now you can see it much better. If you were like in person, if even like with the 5 drops, I could see the layer, but because is the camera that is translating this observation to you, is hard to see when it's like a thin layer. So we just add the extra sample and it would thicken the top layer. It's easier to see. So if the two liquids are not soluble in one another, they are not miscible, it would show 2 layers. And we have the one with the lower density would be on top, higher density down. But if it's 2 layer and you shake it like vigorously and you hold it, still it shows the 2 layers. Same thing happens with the oil and vinegar salad dressing, not soluble. So the compound is not soluble, and I don't have to test for the pH. I would only test with the litmus paper if the sample is soluble. Benzoic acid, I add the benzoic acid to water. I have the water and the benzoic acid. I add, again, I'm going to have to add a little bit. Normally just add 1 tip of a spatula, but because of the camera, I just want to make sure that you could see the particles that are settled at the bottom of the test tube. And I'm going to shake it vigorously and see that the particles are still like settled down at the bottom of the test tube. So it did not dissolve. So it would be counting as insoluble, okay? Insoluble. And when I'm shaking, you could see that the particles are moving also in the liquid, insoluble. It did not dissolve. So I'm going to take these 3 test tubes out and my next solvent. My next solvent is the sodium hydroxide. So in 6 molar sodium hydroxide, I'm using 6 molar sodium hydroxide. Based on the procedure, I would place 1 inch, about 1 inch of the solution in the test tube, in each of the 3 test tubes, and check the solubility for my organic compounds. Now, the ethanol it dissolved in water, there is really no point to check it for sodium hydroxide, because if it dissolves in water, it will dissolve in sodium hydroxide, because sodium hydroxide is made with water. So sodium hydroxide, it's, even if it's 6 molar, mainly is water, is aqueous solution. So if it dissolves in water, it will dissolve in the sodium hydroxide. No need, but you can record your observation. Yes, it's soluble in sodium hydroxide. So ethanol is soluble in sodium hydroxide. Hexane did not dissolve in water, and we are going to test it in sodium hydroxide. Okay, the second layer formed here with sodium hydroxide and hexane, so it's not soluble. For the next test tube, I have sodium hydroxide. I'm going to add benzoic acid. Benzoic acid, because is carboxylic acid is a organic acid, and we have a strong base here. It is expected to dissolve, but I always experimented. I don't go with the expectation. And I want you to look at the reaction and see if it dissolves or not. Okay, because it's a solid compound and it takes time, you have to vigorously shake it. It is disappearing, and the bottom line or the final result here is that this compound had dissolved because it's organic acid. It dissolved in sodium hydroxide. Basically, it reacts with sodium hydroxide and generates a benzoate salt, sodium benzoate salt, and any compound that contains sodium is soluble in aqueous solution. So the product basically dissolved in the in sodium hydroxide. It reacted and then it dissolved. The next solvent that we are testing is HCl. With the HCl, I will add the HCl to the 3 test tubes. Same procedure as before. About 1 inch is approximate. And with the approximate, what we have to be careful is that we don't want our solutions to get saturated. So we can't add too much of a solute and too little of the solvent. But with the procedure that we are doing, we are just adding 1 drop at a time to see if it's soluble or not. It's okay to just use approximate volume of the solvent. First compound I'm adding to the to HCl. Again, it kind of defeats the purpose, is ethanol, because ethanol is soluble in water, and HCl also is an aqueous solution. So it would dissolve, and it did dissolve. I just added like 5-6 drops. It shows only 1 layer. So it is soluble in HCl solution. This is not for all alcohols, but if the alcohol dissolves in water, it will dissolve in HCl and also in NaOH, as you saw earlier. Next compound is hexane in HCl. Hexane in HCl is not expected to dissolve because it's a non-polar compound, and we have polar solvent. So you would shake it well, and again, when you either cork it or you can use gloves and cover the test tube and shake it. But I know, like, I'm just shaking like as vigorous as if I had the gloves. So after shaking, you hold it, look for the layers. Now 2 layers have formed. It means that it's not soluble in HCl. The hexane is not soluble in HCl. Now, HCl with benzoic acid. Benzoic acid is weak acid, HCl is a strong acid. Normally, if I want to precipitate this to get it out of the solution, I would add strong acid. It's not expected to dissolve, but again, I have to do experiment in order to come to conclusion that it's dissolved or not. Now, you just have to shake it just like before and give the same time that we gave to the other solution with the sodium hydroxide, we give the time. But this one is like, it's not floating. The behavior is kind of different. It settles all of a sudden, or as soon as I add, it settles down, which shows more of the behavior of insoluble compound. It settles or it floats on top. Either condition means that is not soluble. If it's like floating inside the liquid, that means something is happening. So in this case, it just settles right away and is not expected to dissolve. So keep that in mind when you are working with the unknown sample. So this was the solubility for the known samples. Okay, now that we are done with the known samples, we are going to test our unknown. We have a liquid unknown for the solubility. We are going to test it in 3 different solvents. The first one was water. In water, so let me just add the solvents first. I have water, sodium hydroxide. Have water, sodium hydroxide, and HCl. Okay. So the first test tube is water, and I'm going to add the unknown. I would add a few drops of the unknown. And again, because of the camera, I'm just going to add extra drops and see if it's soluble or not. And if it's not soluble, then it would be thick enough for you to see it. I would shake it vigorously and wait. Okay, see, droplets of the oil is going down and coming up. A second layer is formed. Okay, so you record your observation based on the how many layers are formed, if it's soluble or is not soluble. For the sodium hydroxide, so this test tube is the sodium hydroxide with the unknown. So I would add the unknown to the sodium hydroxide. Add some color here. When I add this, which I could have added before too, it might make it easier for you to see the layers. See, like the blue color, because this one dissolves, the bromothymol blue is blue color in sodium hydroxide, and then we have that layer of the unknown. Next solvent is HCl. This time I'm going to add the acid-base indicator to show you that, you know, the layers are more distinct. It's easier for you to see it. So this is just a layer of HCl. And now I'm going to add the unknown. So when I add unknown, let's see if I can make it slightly darker for you. Okay, it's easier to see now. Okay. Now I'm adding unknown to the HCl. If it dissolves, it would be one layer. And if it doesn't dissolve, it would form 2 layers, 2 shades of the color. Please record your observation. And if the instruction at any point asks you later to take a screenshot, you will take a screenshot. So this is the solubility of unknown in HCl. We are done with the solubility part.